Hi, my name is Hsin-Liu, and along with Artem, Dementyev, both from the MIT Media Lab, we're here to present NailO, Fingernails as an input surface. And so we're really interested in imagining this future of wearable technology where this miniaturization of electronics allows us to place technology closer and closer to our human bodies to an extent where they might even be able to be embedded. And so really blurring the boundaries between technology and ourselves. However, the acceptability and a lot of the ethical concerns of doing so are still left in question. And so drawing inspiration from the multi-billion-dollar cosmetic industry, we looked into cosmetic extensions as an interesting middle ground. So these cosmetic extensions, when they're attached to a human body, they are very seamless, unobtrusive. They become an extension of your physical body. However, they still give the user the power to remove it at their discretion. So the wearer still has control over the level of intimacy of these extensions to their bodies. And so we are interested in looking at creating wearable devices inspired by the form factor of these cosmetic extensions. And in doing so, we thought there were three main design criteria that must be satisfied. And the first one is these devices, they must be very unobtrusive and very miniaturized for them to blend into the human body. And so we put in significant engineering effort to make this happen, which we'll show a little bit later in the talk. And we also believe these devices, they must be able to afford very natural interactions, which require very low mental loads. And for the third part, because for electronics that get so close to the human body, there is this greater need and desire to be able to personalize the appearance of these devices, so that they're not only aesthetic, but you would want to wear them with you in and out of your daily scenarios, social scenarios, and with you to go with your different clothing. So they must be appealing to wear. And looking at all these possible cosmetic extensions, we landed on the fingernail as a interesting first place to start this exploration. And because if you look at your fingernail, it is a hard surface with no nervous ending, so you can very easily attach a layer of electronic or circuitry on top of it. And also because our hands are very dexterous, so we think they would afford very natural interactions. We were inspired by a lot of amazing related work in this field, such as using fingernails as an output, as a display, or attaching vibration motors on top of the fingernail, or also using the finger pad as an input, and also a lot of Katia Vega's amazing, very artsy, crazy beauty technology work also stimulate a lot of our imagination. And so with NailO, we're presenting using the fingernail as an input surface. And we put in a lot of effort to really miniaturize the device so that everything fits wirelessly onto your fingernail, so that it is sort of like a cosmetic product, the form factor. However, we also engineered for a solution that would allow the wearer to very easily alter the aesthetics of the device.
So this is a NailO mounted on a fingernail. So all the electronics and the battery is embedded in this device. So on the top you can see the capacitive sensing electrodes. There's 9 of them. And we use the conductive inkjet technology to print them. So actually with capacitive sensing, you can put another layer on top. If it's not conductive, it doesn't interfere with the function. So here you can see we can put an art, for example, art layer on top to customize the appearance. So here the device, we broke it down into 4 layers. And I'll talk a little in more detail about the circuit layer here. So there's 3 main chips here. There is a ATmega328. It's the processor, the brain of the device. There is a Bluetooth chip, an RF8001, which is a Bluetooth low energy chip, so you can communicate to a laptop or a smartphone. And also we're using Texas Instruments capacitive sensing chip to get the data, the touch data from the electrodes, and it processes it. So if you look at the side, the device is 4 millimeters thick, and the battery we actually found the smallest battery we could find, which is a 0.5 millimeters thick rechargeable battery. And with this battery, we can get right now 2-hour battery life. But if we optimize further, we can probably go up to more than 10 hours. So here are the gestures that we tested in the user study. there is a swipe gestures. There is a top, down, left, right, and press gestures. And in our software algorithm, we actually we track the centroid. We didn't use machine learning, so it doesn't need any training. And the details of this are in the paper. So here is the gestures in operation.
So we conducted a 10-person user study on the 5 gestures, achieving 92% accuracy. The gesture that gave us the lowest accuracy was the swipe down gesture, because a lot of our right-handed users, when they were swiping down because of the curvature of the nail, it resulted in a misdetection, detecting it as a diagonal left gesture. And in the post-user interview, a lot of users were interested in putting NailO on different fingers, and also not only putting on one NailO, but multiple NailOs to enable cross-finger interaction. And so to show some applications which we think would be useful using NailO. So the first one is remote control when your hands are full. So here we show a scenario of when you're using both of your hands busy soldering, but you need to navigate a data sheet. You can very easily use NailO as a third hand to help you do so. And another example is when you're typing and using, here we show an example of using NailO to help expand the input space of the mobile phone. So to use NailO, very simple swipe gestures to toggle between different keyboards to make the typing process even more seamless. And because of the very small and discrete form factor of NailO, we think it would also enable very private and subtle forms of input. So today, let's say I'm in a meeting, but I get an important text message from my boss, so I can very subtly reply, auto-reply to my boss without disrupting the meeting. And so to further realize this idea of a wearable device very close to your body, we further prototyped NailO with the flexible circuit, working with factories in Shenzhen, as you can see here. And so with this flexible prototype, the interesting part is we were able to manufacture it with double-layered interlocking diamond layer capacitancing electrodes, which allowed us to turn NailO into a XY coordinate touchpad. So it would not only be able to sense the 5 basic gestures, but also we believe with a little bit additional software engineering, it can detect a lot more, even more complicated input gestures. And so we present NailO using the fingernail as an input surface. So it is not only a device that is functional, but we sort of engineered it so that the wearer would very easily be able to alter the appearance by attaching a nail art layer. So it opens it up to become sort of like a canvas for self-expression. And in our future steps, we'll be working on further miniaturizing the sensor so it can go on all fingers, and also to enable more personalized interactions. So thank you very much. We'll be happy to take questions.
We have time for 1 or 2 questions, and as you're finding the microphone, let me. There's no close. All right. What was the question? I just want to ask you. You confused me. Oh, okay. So I just want to say that, I mean, obviously thought of Google Glass, but I just was appalled to see that even the most recent version of, the Gear VR, which I like very much, also has this thing of doing this, the interaction here. So I think if you just hook yourself, I mean, you're probably debating that right now. If you hook yourself in the current evolution with the Gear VR, I suppose you're having a startup right now, and I think this should be a fantastic market for you guys. So. Okay, Dan Ashbrook.
Hi, Dan Ashbrook, Rochester Institute of Technology. I'm curious if you have thought about text input on the thumbnail, and if you think that would be